Pinhole Viewer Lab because we're going to be looking through a tiny little pinhole. And it's going to be hard to see things through a pinhole because you would have to really figure out how to find that object. So it takes a little while, but I really encourage you to try your best to try to figure out where your object is, because there's a lot of cool effects that this simple Pinhole Viewer Lab is going to give you. So first of all, you've got your image here. The end of this pinhole viewer, I notice how there's two parts to it. The end is going to have a piece of foil. You might find a bunch of pieces of foil in there. I want you to create a new one for your group. And you're going to rubber band the foil on just for security. And then you're going to take a tack and put a tiny little hole in it. The smaller the hole, the better, but the smaller the hole, the harder it is to see things. So start with a small one, and you can enlarge it a little bit if you need to. You're going to have in your second tube a screen. It's made out of Scotch tape, so it's really blurry when you're looking at things through this screen. But I do want you to try to see an image through it, whether it's your partners in the lab group or your hand. And you do need a pretty clear light source to do that. So I have a couple of recommendations. What you're trying to observe is the size of the object, the clarity of the object, the brightness of the object, and the orientation. Is the image upright? Is it sideways? Is it upside down? Is it flipped? And in order to do that, you have to have an object that's pretty asymmetric. So I have a light bulb here, which is a great image because it's pretty clear to see. It's direct light. The problem with this light source is it's fairly symmetric, and so it's hard to see the orientation of it. But what you can see from this light source, if you look at it through your pinhole, is the size, the clarity, the brightness. And then when you get into orientation, sorry, Chase, this is not the best lab for you today. When it gets to orientation, what I'm going to do is add a second light bulb because you can see now if the blue is on one side, the red is on the other, how does that image show up on your screen? Now, this is asymmetric in terms of left and right. What I would like you to try to do is either go up to a window or you can step outside, as long as you're being quiet, because I don't want you disturbing the class next door. But as long as you're being fairly quiet, I want you to step outside. Have one of your partners lift one hand up, leave the other hand down, and see if you can see their image in the pinhole viewer. The other option is to hold your pinhole up to the light source. Again, it's going to be hard to focus. And then see if you can see your hand. Your fingers are pretty asymmetric, so it might help you. Or you can look at your partner's hand, but your fingers are asymmetric, and it'll be fairly easy to see the orientation that way. So you have options. You have a light source. You have, in terms of the bright light, this is going to give you probably the best view, but it's hard to see the orientation, so I also want you to try using natural light or a window or one of our classroom lights as best you can. So, all you're doing, this is a quick lab. You're writing the observations for a small pinhole. To get a bigger pinhole, don't make it too big, but just use your tack and kind of roll it around that pinhole to make it slightly bigger. Not that much bigger because I want you to still have it as a pinhole. And then I want you to compare and contrast. Did the small and the enlarged pinhole change the image in terms of size, brightness, clarity, or orientation? And then you're going to create two pinholes.